Before we start talking about the specifics of the ColorMunki, I want to make sure you have a basic understanding of how color works. In the simplest sense, we see because our eyes receive light that's been bouncing around in the world. Our brain interprets the light energy and creates an image. The human eye perceives three primary colors of light: red, green, and blue. By combining varying amounts of these three colors, it's possible to create all the other colors we see. I mix red and green light together to get yellow. If I mix green and blue, I get cyan. And mixing red and blue gives me magenta. Cyan, magenta, and yellow, or CMY. That may sound familiar. These are the opposite colors, the colors used in most types of ink on paper printing. Mix equal parts of cyan, magenta, and yellow, and you get black, or something really close to it. This is the K in CMYK printing. But instead of printing 3 different inks to get black, modern printers simply print black ink to get the same color. And you can get back to red, green, and blue, or RGB, by mixing cyan, magenta, and yellow together. Magenta and yellow make red. Cyan and yellow make green, and cyan and magenta make blue. The easiest way to remember these mixes is to write them down in 2 columns, CMY and RGB. The opposites fall across from each other. Red is opposite cyan, green is opposite magenta, and blue is opposite yellow. To find the mixes, just eliminate the opposite. Here's what I mean. To find which 2 colors make green, eliminate the opposite of green, which is magenta. That leaves cyan and yellow. Cyan and yellow make green. Here's something else to keep in mind. Color is greatly influenced by the other colors around it. Well, that's not exactly true. Actually, our perception is greatly influenced by the colors around whatever we're looking at. Let me demonstrate. You may recognize this. It's a slightly modified color checker by Rite. Take a look at these 2 squares. This one is kind of a dark forest green, and the other is a much more vibrant green, almost day glow. Now watch what happens when I isolate the 2 greens by masking off the surrounding colors. The 2 we were comparing are actually identical. Because of the surrounding colors and shades, our brain perceives them as being very different. Look at this color. How would you describe it? Some might call it simply red or brick. Others might call it terracotta or brown. We're all looking at the same color, but we describe it differently. Well, that same thing is true of digital devices. Color is device dependent, meaning different devices will display a specific color differently. If I scan this color, my scanner will describe it using this set of numbers. To get my display to create the same color on screen may require these values. And when I send the color to my printer, I need to describe it with these values in order to get a match. Juggling the numbers and making the colors match is where the ColorMunki comes in to make life simple again.